Cool. Hi, everyone. My name is Holden. I am in my last semester of the MSDS program, which is exciting. So the project that I'm going to be talking about is a text-based project. So the vast majority of projects that you'll do at UVA are not text-based, but there is one class that is like entirely focused on text, and it's called Exploratory Text Analytics. That's a title that was termed by one of our professors here. And in that class, you'll focus a lot on understanding like long texts. So like books and how trends in stories and things of that nature can be studied within like a certain time period or by a certain author. I am more interested on small text. So think company descriptions or tweets or LinkedIn profile pages. And the approach that you would take to solve those problems are quite different, actually. So what I'm going to be doing is going through a project that I did for that exploratory text analytics course, where I got permission to focus on something that was slightly different than what we had done throughout the program. And that was a really cool opportunity for me because I was able to get permission to do something kind of outside of the curriculum, and then also got to work with my professor every week, sometimes twice a week, independently, to get his expertise because he's like an expert in the field. And he was able to coach me a lot and teach me some of the like deeper natural language processing methodologies that I now am able to employ professionally in my life. So this was a great experience for me, and I'm very happy to present this project. And the way I'm going to structure this is I have put together something called a Jupyter Notebook. I don't know if everyone has experience coding, but typically you would code, I don't know, just in like a file or in some IDE. This is slightly different where you can have code and then immediately see the output from it. And this is really helpful for one, doing testing, but also really helpful for showing some of the visualizations line by line as they're developed. So I'm going to work through this. And what I want to remind you all is like, if you don't feel very comfortable coding, that's fine. You don't have to understand all of the Python that's here. Please like, don't let this be intimidating. What really matters is some of the cool visualizations like that I'm going to show you. There's some like really beautiful visualizations that come about from studying text. And I'm also going to show a few of the more mathematical concepts, but make sure that they're visual. So hopefully they'll be a little easier to digest. So let's start with the initial problem that I was trying to solve. I was curious to see if you could classify a company into a certain industry based on the way that they talk about themselves. So that's not an insignificant, like that's not, it's a pretty big problem. If you think about it, it's like on the surface, you think like, that'll be easy, right? It's like here we have these company descriptions. Are they in healthcare, right? But that actually ends up being really, really difficult. And so the way that I first started approaching this problem, this is where we see in section 1, is how do I even develop a data set to train my model that I'm ultimately going to make on? And there's plenty of choices I could have made. But ultimately what I ended up doing is going to CrunchBase. CrunchBase is like a database for basically all information that's publicly and sometimes privately available on companies, both public and private companies. So what I did was I took a bunch of like company-specific information from them and put together this database of my own that ultimately I would use. So let me show you what that looks like. And I'm going to gloss over a lot of things throughout this presentation just because they're not necessary for you following along and like what really matters. But what really matters is that, and this is true of a lot of like complicated data science problems, is you have this question that you want to solve, and there's just like definitely not any structured data set out there for you to like go for answers, right? And like sometimes it's easy. And when you're in school, you're usually given problems that are simple and like have been solved and they're instructive, right? And that's kind of the beauty of school. But when you start getting outside of the confines of like academia, and you start having to do some kind of messy things. And so that requires me, for example, like scraping a database and basically using the information that is necessary to my problem. And so this is ultimately the type of information that we're working with. And so as we move through this presentation, just try to keep in the back of your mind that what you see right here is the type of stuff that we're talking about. And I'll actually hop over to the comma separated file that I have on it. Is that this is really what it looks like, okay? So we have an organization, like the actual company name. And this is CrunchBase's attempt at identifying what industry it's in, but sometimes this can be a list that's like 20 long, right? So CrunchBase is guessing, they don't know anything. And here's like a full description about the company. These can be maybe like a couple sentences or sometimes up to 2 paragraphs. But this is basically marketing material. And what's happening here is this is like how a company would describe themselves. My thesis was, hey, we have this text, this just small amount of text, maybe a paragraph. Can I identify similarities in the way that companies speak about themselves? And will that allow me to uncover some general truths about language that would allow me to classify a company based on the description of themselves into a certain industry? So that was my ultimate hypothesis. And throughout this, really what I'm doing is just testing a few statistical techniques and trying to identify, like, is it even possible? So step 1 in all data science tasks is, what data am I going to be using, right? And then going out and finding that. And so that's what I just showed you. I went to CrunchBase, I needed some data, and ultimately I had to bring that in. And I'm kind of glossing over it, but like, that is a huge amount of work, right? Like I spent weeks just like getting that data in clean and ready to actually use and like put into some models. And in that cleaning part is right here in section 2. In like data science speak, we call that preprocessing. And really what that looks like is just getting the words into like a format that I can actually use. And for anyone who's interested in statistics, but particularly interested in like linguistics, this is the big limitation of the science as we have it right now, is that everything is statistical. And so if you have a large amount of text, like a computer doesn't actually understand context of the text. They can't read the way that you and I can read, but they can assign numerical values to words and use that as a proxy for determining value. And I'm going to get into that later on. But just keep that in the back of your mind that like that's a huge limitation when you're just using statistics to try to understand human language. Okay, so here is just me pre-processing things. There's really no need to talk too much about it. But ultimately what I'm doing is just trying to get it into a more manageable data set to work with. As I mentioned, CrunchBase had made some guesses around like what industries they are, but that's pretty unreliable. But I still ultimately need a training and a test set. If you can remember from like just the basic stats class, not thinking about natural language processing or anything, but like if you're doing a simple linear regression, like you need a training set and you need a test set. And I needed my training set. And so what I did was I just went through this big CSV, all of the companies that I had, and then I just narrowed it down to the ones where industry groups had only one guess by CrunchBase. So that is like a decision I made. And again, when you're doing these data science projects, there's no one like telling you what's right or wrong. You're kind of making assumptions and testing them out. And I made this assumption because it's all I had to go on, right? And on the one hand, that's not that big of a deal because, you know, CrunchBase was probably right. And but it does lead to some bias when you're thinking about text, right? Because for like what we're working with here, it's like there's ultimately going to skew towards companies that like are obviously a certain industry. So maybe the text is about an airplane company. Like the words that an airplane company is going to use to describe themselves will be very distinct to airplanes, right? And so that'll be obvious to train something on. But maybe it's, I don't know, you just have to think when you're building these models, are you introducing bias by these initial assumptions? And the answer is always yes. And so you're just trying to mitigate it. Okay, so I'm going to keep on going, and I'm going to, apologies for me kind of blowing by a lot of the stuff, but this is really just me pre-processing. Here's a mistake I had made, right? So clearly I had done something wrong with my text processing, so I had to go back and fix that, which I do. All right, so now let's hop over to this next part. And when you're working with text, you want to try to think about like structure and order to text in order to understand it. Again, because like we are humans and we can read and that's fine, but a computer, they need structure. So the like a generally accepted methodology is this thing called OCO, which is like an ordered hierarchy of thinking about like how text is structured. And what that ultimately comes down to would be thinking about it in the context of like the problem that we're trying to solve. You would have like at the top of the hierarchy, like what industry is a company in? Then maybe one rung down, it'd be what is that company? And then rung down from that, you think about the sentence structure, and then you'd go down to just word by word. And just to show you exactly what that means, here we have like a company description. What we would do is break it down by sentence and then by word. And I'll show you visually what that looks like in a second. But in order to get to that point, this is when we start confronting like the limitations of natural language processing through a statistical lens. Now, at the very end of this presentation, I'll talk about some of the exciting like research that's being done in deep learning with natural language processing, research that actually I am actively participating in. And it's very exciting, and it kind of answers a lot of the problems that you'll run into with just using pure stats and numbers to represent language, and actually trying to understand like, what does language really mean and how can a computer learn that? But for right now, because this is just statistics, we're running into some problems, right? So we have all these words and we need to do something called categorical coding, which basically means that if I have a word, I'm just going to assign it a number, and I'm going to use that number to represent it so that my computer can understand it, and I can feed a number to my model instead of just some meaningless word. Okay, so I go through the process, and this is what it looks like, right? So I do this for both the industry that we're operating in, as well as basically every single word that we're operating in. And again, apologies for going a little fast, but here we go. This is this idea of like a library, a token, and a doc. What we're doing is just separating all the text that we have available to us into different styles of hierarchy, right? So we have like our organization, which is the company. We have what we think the industry might be, and then we have that numerical value of what industry they're in. For the document, we do a similar thing, but we actually bring it down to the sentence level. And I'm going to like expand on why all of this matters in the next two Jupyter notebooks, but just keep in mind that like when you're doing these pre-processing steps, none of it makes sense. And like that's kind of the challenge of working with text, especially like when you're doing some pretty advanced stuff with natural language processing, is that for the vast majority of the time you're dealing with it, you don't know what's going on. And so a very critically important step to doing any innovative research in like text-based analysis is that you have to have a deep understanding of the language that you are working with, of the actual text that you're working with. You can't just build a model and feed it random words and expect to get anything interesting out of it. It's a hyper-specific practice where if you are to actually do anything interesting and meaningful in it, you really need to understand the subject of what you're doing. And that's pretty distinct, right? Because there are some instances in machine learning where you can be very proficient in statistics or maybe linear algebra, and that could be enough to produce something valuable. But when it comes to text-based analysis, you actually have to understand the words that you're working with, because a lot of it's really confusing. So right now we're just getting all of the descriptions down to the sentence level and assigning them a numerical value. Again, this is just helpful for our model to ingest, okay, we have sentence number 0, and that will act as a reference later on as we're trying to pull out value and extract value from what ends up being somewhat of a black box of the model that we built. So thinking about like leaving breadcrumbs for yourself, right, in order to find your way home. This is basically what we're doing here, right? Like later on, things are going to get way more complicated. And so we're just allowing just a way to find our way back. So we have all these numerical encodings so that we can like easily understand where things come from. And that, again, just doing that here, but at the word level. And here we get to kind of like that final point in our data. So we took in step 1, just CrunchBase, company specific information. So just paragraphs about companies. And now we're left with this kind of crazy looking data frame. But there's a lot of interesting things going on here. One is something called a POS, which is a part of speech tag. And that's powered by what I think is like an incredibly cool, very powerful hidden Markov model. And what it does is it allows you to identify a word within the context that you find it. So right here, this is like a proper noun, an NNP. And the hidden Markov model is able to identify that the word chili sleep is a proper noun based on this really powerful underlying algorithm beneath it that can say, hey, you use this word, we think it's probably this part of speech. And stepping away from computational linguistics and focusing more on just like literature, understanding syntax and understanding part of speech is really important, right? Because think about some of the use cases for studying language. If you wanted to build maybe a chat bot in order to help like medical patients, right, talk through their problems, right, you would want to make sure that the person who is interacting with that bot at least feels like it's human, right? And a huge component of that is making sure that syntax is correct. And that really starts with part of speech. Think about like Mad Libs, you know, how you played that as a kid, where you could put in any random word, and even if it sounded ridiculous, like structurally, it still made sense because you put a verb in where a verb ought to be. And tracking this is really important when you take these further steps in like interesting natural language processing projects, where you start actually building and generating new text. Understanding part of speech is really important for that. There's a lot of ways to do that, but like I said, this hidden Markov model is probably the most popular for identifying part of speech. But an interesting way that this problem is dealt with so I'll just go back up here really quick, is like, if we have this word chili sleep, it will, you know, the hidden Markov model is basically still making a guess, right? At the end of the day, maybe chili sleep, that's not a great example, but technology is a better example because that's a noun. But maybe technology was used 20 times across like all of the text data that I have. And maybe 5 times it was used as a verb, who knows? But 15, it was used as a noun, right? That hidden Markov model is going to make a guess and say, look, the majority of the time, this was a noun. And so we're going to deem it as a noun. And going back to like how stats play such an important role in a lot of the like natural language processing stuff that goes on here, this is like a great example of that. Okay, so I'm gonna kind of just go past a lot of this now because I think I've given enough background. And so this kind of gets to my first key hypothesis, right? It's like, can I apply that same idea of like using the max part of speech tag to identify the relationship between words and industries, right? So going back to my initial, like, what am I doing in this project? I'm trying to identify like, hey, if there is a description of a company, can I identify if that company is a healthcare company or a tech company, you know? And what I thought is, well, maybe if I redefine the algorithm that identifies like the most likely part of speech tag for a word, but instead train it on the actual industry, maybe that could give me some insight into understanding what it really means to classify text data. And so that's what I set out to try to find out. By the way, the answer is no. That was not a correct hypothesis, but it did get me close, and it actually got me a lot closer to like the end goal. And so this was helpful for me to explore. And basically what I do over the course of this entire rest of this specific Jupyter notebook is test that hypothesis. And I'm going to scroll past it because I just don't think it's totally necessary to go into it, but I will reference this later on. So yeah, keep in mind that like I might come back to this, but for now, I think it's more important to talk about some of the visualizations and what it means to visualize text through a statistical lens, and then use some of like the more complicated like computational stuff in order to like understand, you know, what really matters here. And so, yeah, I think before I get into some of the visualizations, because the visualizations will answer a lot of the questions that come about from this, I'd be curious to hear from people whether you want to like chat in the chat box, or if you want to just unmute and talk. I'm happy to field your questions. The question really comes down to, you know, we have all of this text available to us, but we are severely limited by just, you know, inherently like what statistics allows us to do. You know, I was trying to describe before how, you know, we're encoding words as numbers, but the computer's not actually understanding truly what language is. And so I'm curious, you know, we're at this junction right now before I start training models and everything. What does anyone think about like what are some of the problems we're going to run into? And there are really no wrong answers here. There's a lot of problems with this approach. And so I'm curious, what are some things that you could think of right off the bat that like I might, I should question in this analysis? And there's really no wrong answers.
Hey, my name is Jordan, and I'm just curious, where were you getting the company descriptions from in CrunchBase? Are they coming from like the company's 10Ks?
Yeah, good question. So yeah, I was pulling them from a few different places. One was their 10Ks. Some just had them basically on their profile. And the third was I ripped it from their public LinkedIn profile page.
Mm-hmm. And apologies again, I had to miss the first couple of minutes. Was the end goal, how did you define your end goal for this project? I'm curious because I have an interest in doing something kind of similar to
Cool.
this. I work in tax, and this kind of thing is useful for what I used to do. So
Nice.
I have a particular interest in this area.
Cool. Well, we should talk after too, because this
Yeah,
is
I don't
still
want.
what I do professionally. So I'm definitely obsessed with this stuff. The end goal for me was more exploratory. The end goal that I'm working on now is very discrete. I mean, I did this project about 12 months ago, and I've grown a lot as like a technologist and specifically a natural language processing engineer since then. But at this point in time, when I was still trying to understand the limitations of the technology that was available, what I was curious and identifying is like, look, I know everyone says that computers can't understand language, but like, how far can that really take us, right? Because there are some things that are uniquely human, and that is to understand context, right? But there are some really interesting things that are happening in deep learning that are getting us a lot closer to like artificial intelligence in like the real Turing defined way. And I was curious if this would be an example of coming up on that limitation. Um, and then there's also just like the more, I think, somewhat cynical, just like personal, funny motivation for this is that I think that the way that companies speak about themselves is generally ridiculous. Like I think it's a lot of BS. I think companies love to use fluff words and talk about like everyone's a technology company, right? Like, and what I went into this knowing is that all right, I know that companies do this and it's ridiculous. And is that going to limit my ability to differentiate between um, you know between industries? And ultimately, like my conclusion is pretty much that, right? I it's funny, it's like even if you're in wildly different industries, companies really just all say the same things about themselves. And I explored like ways to mitigate that and actually strip away some of the fluff. And then you actually get to like the underlying value. And I can show that in some of the visualizations later on. And it's actually pretty cool. But I kind of just wanted some statistical confirmation that like companies are ridiculous and how they talk about themselves.
Yeah,
So,
thanks for recapping because I'm sorry I had to miss the first couple of minutes.
oh yeah, no worries at all.
Um,
Um, yeah. So, anything else? First of all.
I don't want to take up too much of the call, so I'd be happy to or the meeting, so I'd be happy to connect later. But one thought I had is, like for example, one thought I have about how you can like parse some of this unstructured data is, I'm just thinking about how manufacturers or distributors write about their business description, and they'll use like they'll use a couple of words: manufactures, produces, makes, and those can kind of help you. I wonder if you could identify those verbs
Yes.
as kind of, and use that to determine what kind of entity they are, and then perhaps identify like products that they might make. Like those would be the nouns in the company description, and then you could kind of like match the verb with the noun. I don't know, you may have already like gotten further on this? This is just something I was.
No, it's a really interesting question. And yeah, I guess I'll just answer that and then get back to the presentation, because your point is so fair. That's like outside the limits of the technology that I was working with in this project 12 months ago. So you actually can't do that. You can kind of replicate it. And I'll show you some visualizations probably in like 5 or 10 minutes of what that looks like. But just to give you like a little taste of like what's out there, there's something called semantic search. And this is pretty fascinating. And I'm actually currently implementing a version of this algorithm into my own work to try to solve a problem that is somewhat related. But it kind of replicates what you're talking about, right? It's like, imagine each one of these points is maybe a product or maybe a company description or both. Maybe it's like, you know, a multidimensional representation of both of those things, whatever. Then if you introduce a new product into it, it would basically use kind of like a nearest neighbors approach of saying, okay, I've kind of seen something like this before. I found it right here in this blue document. Those two things seem kind of similar. So I wonder if that new thing that you just introduced me to is similar enough to say, okay, those two things are the same. And so going to your question about like manufacturing, like I think that there could be some promise in this like interesting new field. And this is like a few years old. And there's been plenty of interesting papers on it, but not a lot of core products. I'm trying to build like a product that implements this idea on one specific use case. So there's hope there. Okay, I'm gonna go back to presenting, but let's definitely connect after because there seems to be a lot of overlap in our interests. Cool, and here we get into more of the visualization part of this. Sorry if the beginning was a little on the dry technical side, but it is important for contextualizing why all of this matters. So in the beginning, I go through just like exploration, because that's a huge part of any new data science project, right? I had mentioned before, you can't do anything meaningful if you don't know what you're working with. And so here, I just go through trying to get a better understanding of the data that I'm working with, right? Right, I'm just looking at like how long are the words, right? And there's really no goal in mind for this part. It's called exploratory like data analysis, right? So like trying to understand like just what's up, you know, what's going on with the data that I'm working with. There aren't really any goals. It's just more exploration. And then maybe goals come from that, but really you're just trying to explore. So here I'm looking at like how long are the words, you know, looking at it from a different perspective, looking at just from individual descriptions. And then I look at it from industry, you know, grouping by industry. And then I look at like the entire length of descriptions. And then I look at, you know, splitting up by industry num. And I'll pause here because this one's particularly interesting. Right now, this industry has a lot more information in it than, for example, this industry. Right? And like that may be a problem. You know, if you think about overfitting of a model, it's very easy to overfit a model when you have a lot of data for that one thing, for that one class, and not a lot of data for the other. Now, that's not always true, which is kind of the cool thing about text, because it's somewhat of an outlier. Like natural language processing, it abides by a lot of statistical rules, but it also is unique in other ways. And this is one of them. It's like in this tiny little underrepresented classification, like maybe I made the example of like the airplane company before, like maybe this is an airplane company. And like, if you were to study the text of an airplane company, you're going to know that it's an airplane company. And like, there's going to be no question, you know, if maybe they are like a food producer, right? It's very unique. And so maybe you can train a model off of that alone because of its uniqueness. And that idea of uniqueness and significance is a really powerful concept that's actually very hard to pin down. And so that brings us into the next section, which is all about statistical significance. There are a bunch of different ways to study that and to define it. I'm going to focus on the idea of ZIFS K, which is basically a way of understanding like term frequency as it relates to like significance. So what that looks like is, here we go, is like all the part of speech. How often are these parts of speech occurring? You can do a similar thing for just the individual words themselves. And then what you're going to want to do, so first of all, before I go into this, here's like an interesting visualization based off part of speech, right? So we have all of the different part of speech tags. So this is a proper noun, this is a regular noun. And this isn't like, this shouldn't be surprising, right? Like nouns are used a lot, right? Verbs are used a lot. But this type of visualization can be very instructive when thinking about that clustering method that I mentioned with like semantic similarity up here. Is like, if you can keep that in the back of your mind and try to understand what it means to be similar, it can be really instructive in identifying like what actually matters, like what models should I use? And I'm realizing I got a chat that I didn't answer. I'll try to expand on it more in a sec, but like, you just got to run all of the statistical tests. Like, you can narrow them down to like ones that have shown significance in like a certain domain in the past. But like what I did is I went through like a bunch of different things, and it's the context of understanding what matters. So understanding the actual text that I'm working with that allows me to identify which test is better than the other. And I'll show what that means right here. So using Zipf's law, gives an understanding of like, okay, so this word occurred a bunch of times in my database, right? But like, what does that really mean, right? Because if we just go based purely off frequency, that could distort things, in which we see right here. So we have the words like and, the, to, of, in. Those are really, really common words. They're the most common words, right? But they're not necessarily significant. And so we can offset that slightly by thinking about what they mean, from a significant standpoint. But before I get into what that means to be significant, here's just like a cool visualization that plots this idea of a Zipf's K, which is like our first introduction to significance, across like how often they're used, right? So this is giving an indication that like at the really far ends of the extreme, like we're getting words that are like never used, right? You get like really, really high Ks. But you're also getting words that are used a ton, right? Because there's this weird offset thing where like, if it's really high frequency, you'll find it up here, but also if it's really unique, you'll also find it up here. So that makes it not that great of a visualization. So what can we do instead? We can plot it on a different axis. So here we have the rank, which means like how often is it used, or like how significant is it used, but also just pure frequency. And if we see up here, we get these like super common words that really don't tell us anything. And we call these stop words in natural language processing. And basically what they mean is like, yeah, they're used a lot and they're really common, but if I remember my ultimate objective, it's classification. I want to know if a company is a tech company or a healthcare company. If I have the word that in the description, I'm never going to be able to delineate between industry. It's useless for the ultimate objective. And so typically what we'll do is we'll just get rid of these guys. But it's funny, it's like, up here, this means nothing. But down here at the very end of the extreme too, maybe some of these are helpful, but a lot of them, and I'll actually go down here, like a lot of them are just nonsense, right? Like that's not going to help me ever, And so as you're going through this exploration, it's exactly that. It's exploration. You're trying to like use these like interesting statistical techniques that are available to us, but then contextualize them at every single step. And so like, if you go through here, it's like, okay, all right, there we see all of our stop words again in the beginning. Maybe in here, potentially there's like a little more value. Out here, we know there's like no value, like what, like no, And so you're just constantly trying to just sanity check yourself as you go through these things. So hopefully that's good enough of an answer for the question I got in the chat. It's nebulous, right? Like there's no right or wrong answer. You're really just trying to extract value and extract meaning where you can. Apologies, I'm just gonna go past all of this because I don't think it's that helpful. But this concept of a document term matrix is really interesting. And let me show you like what that looks like. So here is where we start getting into the classification. Like this is when we start really trying to classify things. So we have the industry on this axis right here. And then we have basically every single word, every unique word that we found in our data set. And then we're just counting how often that word was found in each specific industry. Now, before I continue, can anyone think of like how that might not be the best approach for thinking of what matters? Because remember, this is under the guise of trying to identify significance. Can anyone think of how that might not be the best? Any idea? There are many answers, by the way, so no wrong answers. This is really flawed.
This is Jordan again. I'm kind of thinking like you were saying at the beginning, a lot of companies use these business descriptions to kind of make themselves look good to shareholders and people who might invest and et cetera. And like kind of like positioning yourself for saying that you're like a tech company or that you are involved in tech is kind of common for business descriptions. And so I'm almost imagining that like you're going to have a word like technology appearing over and over again, but that's not really going to tell you much, depending on the industry. Or it's not going to tell you what you would normally assume it would, which is, oh, then this must be a tech company, but it might actually just be we make
Totally.
I don't know.
No, you're right on. It's polarizing in the sense that the words that are super common, even if they're significant, like technology, right? Technology is different from the word and, because there's actually meaning to it, there's value, but it's overused, right? And so you get a situation where on the one side, words are too often used and that can obfuscate the actual classification process. And then on the other end of the extreme, you have really important words that are underrepresented and thus kind of forgotten, right? So when you're working with a massive amount of data like this, we're talking like 45,000 unique factors, right? Like if you have a word that shows up 3 times and you think about like what that means from just, looking at its distribution, like that's 0, right? Like you round to 0. And even if those words like could help you in your classification, if you're training a model off that, that is a huge sparsity issue, Okay, so all like just interesting statistical problems to keep in mind that all have answers to, but none of them are perfect. And so here is like the attempt to rectify that problem. And you basically create a different vector, right? And I'm not going to get into why that is because it's too computational and I don't think it really matters. But just remember that like as you're moving through these problems, through this process of like trying to, explore an interesting, difficult data science problem, like you're going to run into these questions, and most of the time they have answers, and it's really up to you to identify what is the best course of action. So I'm going to scroll down a little bit. Here are some more of these visualizations, but for just the sake of time, I'm going to kind of just gloss over them, but just keep in mind, going back to that question I got in the chat, like so much of this is exploration. And really what I'm trying to understand is, look, are there trends? Can I use any of these visualizations to extract meaning? And the answer is often no. But ultimately, eventually, you can get to the point where the answer is yes. And when you do, it's beautiful because it's like a eureka moment, right? Where you finally get to this point where you're like, okay, that actually makes sense. These scatter plots, I think, are like the closest that you can get to combining complex computational linguistics with like easy to comprehend visualizations, where if you plot all the words that are available to you and just look at like similarity based on location, that's really compelling. And if you are supposed to be a data scientist in a company and you have to explain your thoughts to someone who is not technical, this is a really good method to use because the like actual like vector math behind it definitely supports some of the claims that you can make from it. It's also really easy to digest, right? And there's a better one a little ways down that I'll choose to focus on because I think it has like better words to show what I mean. And you'll understand what I'm talking about. So I'll come back to that in a minute. In this one, there's a lot of bad in here. And what I mean is like, some things work really well in certain contexts and not all in others. So like I said, this class was all about like long form text, which is fundamentally different than short text, right? And so what I'm doing here is really just testing a lot of these hypotheses, and then identifying like, hey, what's not working, right? Here's a great example of like some messy data, right? Somehow some stripped URL made its way in here. This isn't going to help anyone ever. And like, basically, I spend hours after this getting rid of that data and cleaning it up. And I should have figured this out earlier in my analysis, but I didn't. So at this point, I'm like, okay, well, now I have to kind of retrace my steps and make sure that my data is a little cleaner than I thought it was. And that's okay, right? Like, so much of these projects are just going back and realizing that you were so wrong and then trying to like rectify that. And that's fine, because all of this is exploration and it should be fun. So I think that's why I like it so much. Okay, so I'm gonna try to just gloss over a lot of this because I do want to allow for questions, but there's still a few particularly interesting things that I see. This being one of them, right? So here we have listed every single industry and then just a collection of words plotted with how many times they were used. And this is bumping into that problem of like statistical significance, where it's, you have a lot of zeros, right? And when you have a lot of zeros, then things get down-weighted or up-weighted like this. This is a ton of times that the word was used, but contextually, it still is very close to zero. It's farther from zero than the number 2, still really close to zero. So how do you actually care about something like this? And in deep learning, you run into a similar problem where you're creating these like really deep convolutional neural networks where every individual node has like a weighting associated with it. And as your model gets increasingly complex, which also applies to text stuff, as you get more and more text, but going back to the convolutional thing, like as models get really, really big, the individual weights get infinitesimally small. And so trying to identify like, well, what actually matters when you have all of this data is a really big problem that you'll face as a data scientist in thinking about like, okay, what actually matters, and just constantly sanity checking yourself. All right, I really just want to show this one last visualization. And then I think it might be good to do some questions. I can talk about what I'm currently working on that is an extension of this that uses deep learning instead of some of these like kind of limited statistical techniques. Sorry for going so fast through all this. Hope it's not making anyone sick. Here's a pretty interesting one. So this is basically like the first version of like a classification attempt. So here in the topic ID, what I'm trying to do is, and this is like very what they call black boxy. It's using something called PCA to try to identify trends in words without like really being able to explain them. So what you're mathematically doing is translating them onto a different dimension. Obviously, it's more complex than that. But really, what I think is cool about this is like, if you have all of these words, what it's telling you is like, hey, we have all of this content and we're grouping them together into things that we think might be topics. We can't label that topic. We don't know what it is. That's up for you to decide, but maybe check that out. And so here are some cool visualizations that show that, right? And if we scroll down a little bit more, you can cluster these topics in a way that's like pretty cool. And there are all of these different algorithms that you can use to actually identify the clustering. And again, you'll just have to do a little bit of trial and error and see which one makes the most sense to you. There's never a one size fits all approach, but here we go. Here are like all of the different topics that this outputted. And then here is using like Manhattan distance, identifying what is truly similar. And sometimes it doesn't make sense at all, but it's a pretty good tool for seeing like, okay, maybe there are a lot of overlaps, right? And if you can extract value from that and use that in your model, then you're in good shape. The final visualization is here. And this is actually the big motivation for like my current research and what I'm doing. And I think I'll probably end up wrapping it up here because this is kind of the beauty of it, right? So before I talk about that really quick, on this section, I spend a ton of time going through like all of these different statistical techniques, trying to test them out, basically to no avail, right? There was just, as I said earlier, like there's just too much overlap in the way that companies talk about themselves to ultimately distinguish in a way that was meaningful. On top of that, the training data that I used was so limited by what I had available to me. Remember I made that first initial assumption that I was only going to train off of companies that only had a single industry classification. And what that skewed towards is like really extreme language. So I trained off of like airplane companies or biomedical engineering companies. And that's not great. And there's not a whole lot I can do to circumvent that problem. I could get more training data, it's true. But it's just kind of the problem that you run into, especially with like multi-class classification problems, which, outside of the context of language, you probably have experienced in statistics courses where like they talk about, the curse of dimensionality, where if you have a certain amount of data, but a ton of different classes that you're trying to classify in, when you're training your model, ultimately, if you only have like some classes that maybe have 0 pieces of data to support them, how are you ever going to train a model to accurately classify them? Now, deep learning answers some of those problems, which is great, and that's the stuff I'm currently doing. But when you're doing these types of things, you really have to keep in mind what it means to like accurately classify something. So that's I'd probably say is like the best takeaway you could take from this is like a lot of this is exploration, and there's some severe limits in the technology that if you're going to do something meaningful, you really have to appreciate. But then I'll end on what I think is like a very pretty visualization before I start taking your questions. Here we have 2 axes that are basically, one is about like a term of significance, and then the other is based on PCA analysis. It doesn't really matter what those 2 like axes mean or the new dimensions that we're translating the data onto, but what matters is that what we're left with is this very cool looking scatter plot, this just interesting mess of words, where if you dive in and actually look, you can start to see that like there are similarities between the things that get paired together in this model. And when I was doing this 12 months ago, I don't think I realized how powerful this was. But what I'm realizing now is that like this idea of looking at words, plotting them on a plane, and understanding their similarity is actually like the closest that we can get currently to giving a computer the chance of really appreciating the context of language. And so for anyone who's interested in computational linguistics, the research shows that like this is the most promising avenue. And I'm really excited to be studying it myself and taking it to the next level.